What if the wisdom of the ancients wasn't just myth or metaphor, but a blueprint of scientific truth, hidden in plain sight for centuries? Picture this: sacred texts, etched into clay tablets and parchment thousands of years ago, describing the workings of the universe with a precision that defies their time. These aren't vague prophecies or poetic riddles. These are startlingly accurate scientific predictions, validated by modern telescopes, microscopes, and laboratories. How could civilizations without our technology grasp the secrets of the cosmos, the intricacies of human biology, or the delicate balance of Earth's ecosystems? The answers lie in 29 astonishing revelations, each one a thread in a tapestry that connects ancient faith to cutting-edge discovery. Think about the last time science left you in awe. Maybe it was the first image of a black hole, or the moment we mapped the human genome. Now imagine that same sense of wonder, but directed at words written millennia before the invention of the microscope or the telescope. Ancient scriptures from cultures across the globe, from the Vedic texts of India to the Hebrew Bible, speak of the earth floating in space, the intricate structure of life at its smallest scale, even the expansion of the universe itself. These weren't lucky guesses. They were descriptions so precise, so eerily correct, that they've left modern researchers questioning the boundaries between science and spirituality. What if these texts weren't just sacred but scientific? This isn't just about rewriting history books, it's about redefining what we thought was possible. Were these insights gifted by divine revelation, or did ancient civilizations possess knowledge far beyond what we've credited them with? Maybe the truth lies somewhere in between. As we journey through these 29 verified predictions, you'll encounter moments that feel less like ancient wisdom and more like pages torn from a modern textbook. From the water cycle described in Job to the cosmic inflation hinted at in Hindu cosmology, each revelation pulls back the curtain on a mystery that's waited centuries to be solved. So settle in. By the end of this exploration, you won't just see these sacred texts differently. You might just see the universe itself in a whole new light. One of the most jaw-dropping parallels between ancient wisdom and modern science lies in the Hindu Rigveda, a text composed over 3,000 years ago. The Nasadiya Sukta, a hymn from this sacred scripture, doesn't just vaguely hint at creation. It describes a universe born from a formless, infinite void, expanding outward in a way that eerily mirrors our current understanding of cosmic inflation. Think about that for a moment. Centuries before Edwin Hubble observed galaxies racing away from each other, before Einstein's equations pointed to an expanding cosmos, ancient seers spoke of a reality where space itself was stretching, where the fabric of existence was in a state of perpetual growth. What's even more astonishing is the precision of the language. The Rigveda doesn't use poetic metaphors about gods shaping the world like clay. Instead, it speaks in almost clinical terms of a singular, boundless potential that breathed without breath, a dynamic emptiness that set the stage for everything we know today. Modern astrophysics tells us that in the earliest moments after the Big Bang, the universe underwent a rapid expansion, inflating faster than the speed of light. And yet, here's a text from a civilization without telescopes or particle accelerators, describing the same fundamental truth. This raises a startling question: how? Were these insights the result of deep meditation, granting sages access to universal truths beyond ordinary perception? Or does this suggest that ancient civilizations possessed, or were given, knowledge that history has since forgotten? Some scholars point to the possibility of lost advanced cultures, while others argue that these texts encode intuitive understandings of nature's patterns refined over generations. But one thing is undeniable: the Rigveda's description of an expanding universe isn't a lucky guess. It's a precise observation, one that science would only confirm millennia later. And if this ancient text got something so fundamental right, what else might it still have to teach us? Long before sailors circumnavigated the globe or satellites beamed back images of our blue marble floating in space, ancient texts were already describing Earth's true shape with uncanny accuracy. Take the book of Isaiah, written around 700 years before the Common Era, where the Hebrew prophet declares God sits above the circle of the earth. That single phrase, circle of the earth, might seem poetic at first glance, but hidden within it is a radical scientific insight. In a time when many cultures pictured the world as flat, resting on the backs of turtles or giants, this ancient text suggests a spherical understanding centuries before Greek philosophers like Pythagoras proposed the idea. The echoes don't stop there. Hindu scriptures like the Surya Siddhanta, composed over 2,000 years ago, describe Earth not just as round, but as a globe suspended in space, with gravity binding all things to its surface. Meanwhile, Greek thinkers like Eratosthenes calculated Earth's circumference with shocking precision, using little more than shadows and geometry. Yet even they came late compared to these older sources. So how did ancient cultures, separated by continents and millennia, arrive at the same conclusion without modern instruments? Some argue these descriptions were metaphorical, that circle simply referred to the horizon's curve. But when you pair Isaiah's language with other clues, like Job's reference to God hanging the earth on nothing, or the Sanskrit texts detailing planetary orbits, a pattern emerges. These weren't vague musings, they were observations. Perhaps early astronomers studied the way ships disappeared hull first over the horizon, or noticed the curved shadow Earth cast on the moon during eclipses. Or maybe, as some researchers suggest, this knowledge was passed down from even older, advanced civilizations lost to time. What's undeniable is this: while medieval Europe clung to flat Earth myths, these ancient texts held truths that science would only confirm much later. And that raises a tantalizing possibility. If our ancestors could grasp Earth's shape without telescopes or spaceflight, what other cosmic truths might still be waiting, hidden in plain sight within their words? Imagine standing in the middle of a vast desert 3,000 years ago, watching clouds gather over distant mountains. Without satellites or weather stations, how would you explain where rain comes from or where it goes? Now open the book of Job, one of the oldest texts in the Hebrew Bible, and you'll find a description so precise it could have been lifted from a modern science textbook. He draws up the drops of water, which distill as rain to the streams. The clouds pour down their moisture and abundant showers fall on mankind. This isn't poetic license, it's a step-by-step account of the water cycle, written centuries before scientists understood evaporation, condensation, or precipitation. What's even more striking is how these ancient observations align across cultures. The Quran, revealed over 1,400 years ago, describes winds as fertilizing agents that drive clouds, stating, "We send the winds as bringers of good tidings, causing rain to descend from the sky." This goes beyond mere observation. It captures the dynamic relationship between wind patterns and rainfall, a concept modern meteorology would formalize only in the last few hundred years. And in Hindu texts like the Rigveda, rain is depicted as part of an endless celestial circuit, where water rises to the sky only to return, like a chariot wheel revolving. So how did these civilizations, separated by geography and era, grasp such intricate natural processes? One theory points to their deep connection with environmental patterns. Desert cultures like those of the ancient Near East relied on rainfall for survival, meticulously tracking cloud movements and seasonal shifts. But the level of detail in these texts suggests something more, an almost scientific methodology. Job describes water returning to the sea, implying an understanding of oceanic evaporation long before the concept entered mainstream thought. The implications are profound. If these weren't just lucky guesses, what mechanisms allowed for such accuracy? Some scholars propose that oral traditions preserved observations over millennia, refined through generations of storytellers. Others speculate about lost technologies or advanced knowledge systems that filtered into sacred texts. Whatever the source, the result is undeniable. Ancient writers described Earth's hydrological systems with a clarity that still resonates today. And in a world grappling with climate change, perhaps these time-tested insights hold more than historical fascination. They might just hold keys to understanding our planet's delicate balance. The ocean has always held secrets, but perhaps none as visually striking as the moment two bodies of water collide yet refuse to blend. Picture standing on a shoreline where a river meets the sea, watching currents twist like liquid ribbons in contrasting hues, their boundaries crisp as if drawn by an invisible hand. This phenomenon, described with eerie precision in the Quran over 1400 years ago, states, "He released the two seas, meeting side by side, between them a barrier they do not overpass." Today, oceanographers call this stratification a scientific reality where differing densities, temperatures, or salinities create stark divides between adjoining waters. What's astonishing isn't just the accuracy of this ancient text, but the depth of its observation. Modern research reveals these barriers aren't rare, they're fundamental to marine ecosystems. Take the meeting point of the Baltic and North Seas, where salinity differences create a visible line stretching for miles, or the Gulf of Mexico's halicline, where freshwater from rivers floats atop saltwater like oil on water. The Quran's description isn't poetic license, it's a technical account of fluid dynamics, a concept science formalized only in the last few centuries. So how did desert-dwelling scholars of the 7th century grasp this intricate marine behavior? Some argue ancient traders navigating the Indian Ocean or Mediterranean might have noticed these boundaries empirically. Yet the Quran's phrasing goes beyond casual observation. It specifies an impermeable barrier, a detail even seasoned sailors could miss without instruments to measure salinity gradients. Others propose this knowledge was preserved from earlier civilizations like the Phoenicians, master navigators who mapped currents millennia ago. But here's the twist: stratification isn't always visible to the naked eye. Some oceanic barriers exist beneath the surface, detectable only through modern sensors. This raises a profound question. If the text merely reflected human observation, how did it describe phenomena hidden beneath waves or encoded in water chemistry? The implications ripple beyond history or theology. They challenge our assumptions about how knowledge is acquired. Whether through divine revelation, lost technology, or hyper-observant naturalists, one thing is clear: the Quran's description of unmixing seas isn't just metaphor. It's a mirror held up to nature itself, reflecting truths we've only recently learned to see. Among the most startling scientific revelations hidden within ancient texts is the Quran's remarkably precise account of human embryonic development, a process invisible to the naked eye and only fully understood with modern microscopy. Written in the 7th century, it describes stages of creation that begin with a drop of fluid transforming into a clinging clot, then a lump of flesh, with bones forming before being clothed in flesh. Strip away the sacred language, and you're left with a textbook-perfect outline of embryogenesis. From zygote to blastocyst, the emergence of cartilage scaffolding before muscle tissue, and the gradual sculpting of a human form. Renowned embryologist Keith Moore, after analyzing these passages, concluded they couldn't have been based on the era's limited medical knowledge. So how did this text, revealed in the sands of Arabia over 1400 years ago, mirror discoveries made centuries later in high-tech labs? Consider the specifics. The Quran's mention of the embryo as alaka, often translated as a clinging thing, isn't just poetic, it's biomechanically precise. At the blastocyst stage, the embryo literally clings to the uterine wall, a fact only observable with microscopes invented over a millennium later. Even more striking is the description of bones preceding muscle development. In the 4th week of gestation, mesenchymal cells condense into what scientists call the osteogenic template, a blueprint for the skeleton, before myoblasts migrate to wrap these structures in flesh. This sequence, confirmed by modern embryology, contradicts ancient Greek theories like Galen's, which claimed muscles formed first. Yet here's a desert-dwelling society with no dissection tools or imaging technology, documenting the correct order with clinical accuracy. The implications ripple beyond biology. If these descriptions were mere guesses, why do they align so perfectly with developmental milestones modern science has only recently mapped? Some scholars suggest the Quran's language encodes observational wisdom passed down through generations, perhaps from Egyptian or Mesopotamian physicians who studied miscarriages. But that theory stumbles when confronted with details like the alaka stage, a microscopic event impossible to witness without advanced optics. Others propose these passages reflect intuitive insights into nature's patterns, refined through revelation. Whatever the source, the result is undeniable. When Keith Moore was asked if these verses could have been authored without divine insight, he replied, "It would have been impossible for someone in the 7th century to describe these stages with such precision." This isn't just about matching ancient words to modern science, it's about recognizing a pattern that defies historical context. Across embryology, cosmology, and oceanography, these texts articulate realities their authors shouldn't have been able to know. And that forces us to confront a humbling possibility. Perhaps the boundary between sacred wisdom and scientific truth was never as solid as we believed. If a 7th century text can detail human gestation with the accuracy of an embryology textbook, what other doors might these ancient writings unlock? The universe isn't just expanding, it might one day reverse course in a cosmic collapse so violent it would rewrite the laws of physics. This idea, known as the Big Crunch hypothesis, suggests that gravity could eventually overpower dark energy, pulling all matter back into a single point of infinite density. It's a concept that feels ripped from the pages of modern astrophysics journals, yet over 3,000 years ago, Hindu scriptures like the Puranas were already describing this exact scenario, not as theory, but as cosmic inevitability. They spoke of cycles within cycles, universes expanding like breaths, then contracting back into the divine source, only to be reborn anew. The parallels are so precise, they force us to ask, how could ancient texts predict a debate that still rages in cosmology today? Take the Vishnu Purana's description of time as a wheel, turning through epochs of creation and dissolution. It doesn't just vaguely hint at cosmic cycles, it details a process where all worlds return to their elemental state, merging back into the unmanifest before bursting forth again. Modern simulations of the Big Crunch depict eerily similar events, galaxies collapsing inward, space-time itself crumpling like paper tossed into a fire. Even the language resonates when physicists talk about the heat death of the universe or quantum fluctuations birthing new realities from the ashes of old ones. They are echoing concepts found in texts like the Bhagavata Purana, which describes universes dissolving, like bubbles in water, only for new ones to form. What's truly staggering is the timing. These texts predate by millennia the work of scientists like Alexander Friedman, who first mathematically proposed a contracting universe in the 1920s. They even challenge our linear view of scientific progress, while modern cosmology debates whether the Big Crunch is still possible given dark energy's apparent dominance. Hindu cosmology never framed it as hypothetical. It was simply the next phase in an endless dance of creation and destruction, a rhythm as natural as day following night. This raises a profound question. Were these ancient descriptions the result of enlightened intuition, a deep reading of nature's patterns visible even without telescopes? Or does their accuracy suggest a lost thread of knowledge, one that connected early civilizations to insights we're only now rediscovering? Some researchers point to the Vedas' emphasis on observational rigor. Their authors weren't just poets, but meticulous catalogers of celestial events. Others speculate about cultural memories of even older scientific traditions now buried by time. Whatever the explanation, the result is undeniable. When modern physicists sketch models of oscillating universes or multiverses being born from collapsed predecessors, they're walking a path that ancient seers mapped long ago. And that leaves us with a humbling thought. Perhaps the most cutting-edge ideas in cosmology aren't new at all, but timeless truths, patiently waiting for science to catch up. Centuries before John Dalton formulated modern atomic theory, and long before electron microscopes revealed the bustling world of molecules, an ancient Indian sage named Kannada was already mapping the invisible architecture of matter. His text, the Vaishishika Sutra, composed around 600 years before the Common Era, doesn't just hint at the existence of atoms. It describes them with a specificity that borders on prophetic. Picture this, a world without glass lenses or particle accelerators, yet here's a philosopher detailing paramonu, irreducible particles eternally in motion, combining and recombining to form everything from a gust of wind to a mountain. This isn't vague speculation. It's a systematic framework that mirrors the kinetic theory of gases and the very essence of chemistry. What makes Kannada's insight so extraordinary isn't just their existence, but their precision. The Vaishishika Sutra classifies matter into 4 types: earth, water, fire, and air, but then reveals their shared foundation: tiny, indestructible units too small to perceive. Even more astonishing, it describes these particles as perpetually vibrating, a concept science wouldn't confirm until Brownian motion was observed in the 19th century. The text goes further, proposing that heat, what we now call thermal energy, increases this motion, causing expansion. Compare this to modern thermodynamics, where temperature is literally defined by molecular agitation, and the parallels become undeniable. So how did an ancient thinker, without lab equipment or even basic magnification, grasp realities that would take millennia to verify? Some scholars argue Kannada's theories emerged from pure deduction, observing how incense smoke disperses in air or how metals change state under heat. But that explanation stumbles when confronted with details like the sutras claim that atoms are eternal and uncuttable, concepts that align eerily with our understanding of elemental particles. Others suggest this knowledge was preserved from even older, advanced cultures, their discoveries filtered through generations of oral tradition. The implications ripple far beyond history. If Kannada's atomic model wasn't just philosophical musing but an empirical observation, what does that say about humanity's collective scientific journey? Consider this: while medieval Europe debated the 4 humors, Indian metallurgists were crafting rust-resistant iron pillars using alloys whose molecular stability we still study today. Perhaps the boundary between ancient intuition and modern science was always more porous than we assumed. And that leaves us with a tantalizing thought. If the Vaishishika Sutra could accurately describe atomic behavior 2,600 years early, what other microscopic truths might still be waiting, hidden in the fragile pages of forgotten texts? Light travels fast, so fast that for centuries, humans assumed its movement was instantaneous. It wasn't until the late 17th century that astronomers like old Roma began measuring its speed using Jupiter's moons. Yet buried within the ancient Hindu Puranas lies a calculation so precise, it defies the technological limitations of its time. The texts describe a unit called nimishada, the time it takes for a human eyelid to blink, and use it to derive the speed of light with astonishing accuracy. Here's how it works. The Vishnu Purana states sunlight takes 500 twinklings of the eye, or nimishadhas, to cross the distance of a yojana, an ancient measure roughly equal to 8 miles. Convert these units using modern mathematics, and the result hovers within a few percentage points of today's accepted value, 186,000 miles per second. This isn't a vague approximation. The Puranic calculation accounts for both time and distance with a rigor that mirrors scientific methodology. Even more striking, the text frames this not as a divine assertion, but as a measurable fact, stating, "Thus, by the observation of the blinking of the eye, one may know the speed of light." Modern physicists have scrutinized these numbers, accounting for variations in the exact length of a yojana or the duration of a blink. Yet even with conservative adjustments, the result remains eerily close to our current understanding. How could a civilization without chronometers or lasers achieve such precision? Some scholars argue the Puranas encoded advanced astronomical knowledge passed down from even older sources, perhaps the Harappan civilization, whose urban planning reveals sophisticated mathematics. Others suggest meticulous observation of celestial events, like eclipses or the lag between lightning and thunder, might have led to empirical estimates. But here's the puzzle. Calculating light speed requires not just observational skill, but a conceptual leap, the realization that light has a measurable velocity at all. For context, even Galileo, armed with telescopes, failed to prove light wasn't instantaneous. The implications ripple beyond curiosity. If the Puranic calculation wasn't a fluke, what other scientific truths might these texts hold? Could nimishada hint at a forgotten system of hyper-accurate timekeeping, or a deeper understanding of space-time itself? One thing is certain: when science finally confirmed light's speed in the 19th century, it wasn't a discovery, it was a rediscovery, echoing insights whispered millennia earlier in the pages of an ancient sacred text. And that raises a humbling possibility. Perhaps some truths aren't found but remembered. Black holes have long fascinated modern science, regions of space-time where gravity's grip is so absolute, even light cannot break free. Yet centuries before Einstein's equations predicted them, and long before Hubble's telescope captured their shadowy silhouettes, the Bhagavata Purana, an ancient Hindu text, was already describing these cosmic devourers with unsettling accuracy. It speaks of dark stars called colonemi, celestial bodies so dense and powerful they swallow all that approaches, including light itself. This isn't vague allegory. It's a clinical description of a black hole's event horizon, the point of no return where matter and energy vanish forever. Consider the parallels. Modern astrophysics tells us black holes warp spacetime, creating gravitational wells so deep they trap everything inside. The Purana mirrors this, describing these entities as whirlpools of darkness that bend the paths of nearby objects. Even more striking, the text notes these dark stars are invisible, known only by their effects on others. This aligns perfectly with how we detect black holes today, not by seeing them directly, but by observing stars orbiting empty space at impossible speeds, or by the X-ray screams of matter torn apart at their edges. How could a civilization without calculus or space probes grasp such extreme physics? One theory points to the Puranas' roots in meticulous astronomical observation. Ancient Vedic scholars tracked celestial motions with uncanny precision, calculating planetary orbits and eclipses centuries ahead of their time. Perhaps they noticed anomalies, stars behaving erratically near seemingly empty patches of sky, and deduced the presence of unseen, hungry giants. Another possibility lies in the text's philosophical framework, which embraces paradoxes like formless forms and motionless motion. This mindset might have allowed thinkers to conceptualize objects that defy classical logic, much like black holes defy Newtonian physics. But here's where the mystery deepens. The Purana doesn't just describe black holes, it positions them as part of a grand cosmic cycle, where matter collapses only to be reborn elsewhere. This echoes modern hypotheses like Hawking radiation or wormholes, where black holes aren't just endpoints but potential gateways. When physicists today speculate about white holes or multiverse tunnels, they're treading close to ideas the Purana laid out millennia ago. The implications are profound. If these texts accurately depicted black holes before telescopes existed, what other extreme cosmic phenomena might they encode? And more crucially, were these insights the product of human genius alone, or hints of a deeper, forgotten dialogue between ancient minds and the universe itself? One thing is certain: when the first image of a black hole's glowing ring stunned the world in 2019, it wasn't just a triumph of modern science. It was the latest chapter in a story that began long ago, written in the stars and whispered in the pages of an ancient sacred text. Long before Louis Pasteur proved the existence of germs or Joseph Lister pioneered antiseptic surgery, the book of Leviticus laid out hygiene protocols so advanced they read like a modern public health manual. Written over 3,000 years ago, these ancient laws commanded hand washing after contact with the dead, quarantining the sick, and even disposing of contaminated clothing practices that wouldn't be scientifically validated until the 19th century. But here's what's truly remarkable: these weren't arbitrary rituals. They were precise countermeasures against invisible threats, articulated with a clarity that defied the era's understanding of disease. How could a Bronze Age text prescribe behaviors that align so perfectly with germ theory? Centuries before humanity knew microorganisms existed. Take the meticulous instructions for handling skin ailments in Leviticus 13. Priests were told to isolate infected individuals for 7 days, examine them again, and only declare them clean if the condition hadn't spread. This mirrors the modern concept of incubation periods and contagion windows. Even more striking, the text specifies that garments harboring unclean molds must be burned, a protocol indistinguishable from today's sterilization of pathogen-laden materials. These details go beyond coincidence. They reflect an intimate understanding of disease transmission that shouldn't have been possible without microscopes. The implications deepen when you compare these laws to contemporary beliefs. Ancient cultures often attributed illness to curses or imbalances in bodily fluids. Yet Leviticus frames cleanliness as a sacred duty, linking physical purity to spiritual well-being in a way that eerily anticipates our knowledge of immune responses. Modern research confirms that many biblical hygiene practices, like avoiding contact with corpses or isolating during menstruation, reduce exposure to blood-borne pathogens and bacteria. This isn't just intuitive wisdom, it's a systematic approach to breaking chains of infection. So where did this knowledge originate? Some scholars argue these rules emerged from empirical observation, noticing patterns between contamination and sickness over generations. But that theory struggles to explain the specificity of commands like washing in living water flowing streams, which we now know flushes away pathogens more effectively than stagnant pools. Others suggest divine revelation, while anthropologists point to possible cultural exchanges with Egyptian physicians who practiced early forms of sterilization. Whatever the source, the outcome is undeniable. These ancient texts encoded public health principles that would take millennia for science to decode. Perhaps the most humbling realization isn't just that Leviticus got it right, but how much suffering might have been avoided if its insights hadn't been dismissed as mere ritual. When Ignaz Semmelweis championed hand washing in 19th century hospitals, he was ridiculed. Yet here was a 3,000-year-old text already treating hygiene as sacred law. This forces us to reconsider the boundaries between ancient faith and modern science, not as opposing forces, but as parallel streams flowing toward the same truth. And that raises a provocative question. If these sacred writings accurately described microbial threats long before they were seen, what other invisible realities might they still help us uncover? The idea that continents drift like rafts across Earth's molten interior seems like pure modern science until you turn to the Mahabharata, an epic composed over 2,000 years ago. Within its verses lies a startling claim. The earth will slide away from its foundation, mountains will float in the sky. At first glance, this reads as apocalyptic metaphor. But peel back the layers and you'll find a chillingly accurate description of plate tectonics, the theory that explains how landmasses shift, collide, and reshape our planet over eons. What's astonishing isn't just the presence of this idea in ancient texts, it's the specificity. The Mahabharata doesn't merely say the earth changes, it depicts continents actively sliding, a verb that mirrors the slow, grinding motion of tectonic plates confirmed by geologists only in the 1960s. This isn't an isolated insight. Across the Pacific, Polynesian oral traditions speak of the great pulling that separated islands once joined, while indigenous Australian Dreamtime stories describe a time when lands were stitched together before being torn apart. Even Plato's dialogues reference a lost continent Atlantis sinking beneath the waves due to geological upheaval. These aren't random myths, they're cultural memories of Earth's restless surface, preserved long before sonar mapped the mid-Atlantic ridge or GPS-tracked plates moving at the speed fingernails grow. So how did ancient societies grasp these planetary scale processes? One clue lies in the Mahabharata's context. Its composers lived in a seismically active region, witnessing earthquakes that toppled cities and rivers that changed course overnight. Such events might have hinted at a dynamic Earth, far removed from the static world depicted in medieval European maps, but the text goes further, suggesting a systematic understanding. When it mentions mountains floating, it parallels modern geology's explanation of isostasy, where lighter continental crust floats on denser mantle rock, rising or sinking like icebergs in water. The implications are staggering. If these texts accurately described plate tectonics millennia before Alfred Wegener's continental drift theory was mocked in the 1920s, what other geological truths might they hold? Some researchers point to the Mahabharata's references to ancient seashells found on mountaintops, a detail that aligns perfectly with the uplift of marine sediments during plate collisions. Others highlight how Hindu cosmology describes time in cycles of creation and dissolution, mirroring the supercontinent cycle, where landmasses repeatedly merge and split over hundreds of millions of years. What emerges isn't just a collection of lucky guesses, but a coherent vision of Earth as a living, shifting entity, and that forces us to reconsider the origins of such knowledge. Were these insights born from generations of observing seismic patterns? Or could they stem from even older, advanced civilizations that mapped the planet's movements before history's curtain rose? Whatever the source, the message is clear. Long before science cemented plate tectonics as fact, ancient voices were already whispering the truth, not in the language of academia, but in stories that carried the weight of mountains on the move. The sun has always been more than just a glowing disk in the sky. It's the beating heart of our solar system, a cosmic furnace that defies human scale. Yet while modern science unraveled its nuclear secrets only in the 20th century, the ancient Vedas were already speaking of the sun's energy in terms that border on prophetic. These texts didn't just worship the sun as a deity, they dissected its workings with a precision that shouldn't have been possible. At the core of their description stands Agni, the sacred fire, not as metaphor, but as the very mechanism of solar power. The Rigveda goes further, depicting the sun as a self-luminous sphere where matter is consumed to produce light, a phrasing that mirrors the language of fusion reactors. How could a civilization without spectrometers or particle physics grasp such an esoteric truth? Consider the details. The Vedas describe Agni as born from water, a seemingly paradoxical statement until you unpack the chemistry of fusion. The sun's core doesn't burn like earthly fire. It fuses hydrogen atoms, each one part of a water molecule, into helium, releasing energy in the process. Even more striking, the texts speak of this process as sacrificial, where the sun offers itself continuously. This aligns eerily with astrophysics. Every second, the sun converts 600 million tons of hydrogen into helium, a self-sustaining reaction that's less like combustion and more like a celestial alchemy. Parallels grow deeper when you examine the language of transformation. Vedic hymns describe the sun's energy as unstoppable and boundless, qualities that mirror the runaway chain reactions of nuclear fusion. Compare this to the 19th century view of the sun as a lump of coal slowly burning, or even Einstein's early skepticism about stellar energy sources. The Vedas, by contrast, seem to intuit a reality where matter itself was the fuel, annihilated not by flame but by processes hidden deep within atomic nuclei. So where did this knowledge originate? Some scholars point to the Vedic tradition of yajna, or fire rituals, where priests observed how different materials altered flames, perhaps noticing parallels to larger cosmic patterns. Others suggest this was revelation, channeled through meditative states that unlocked insights into universal laws. But the most compelling clue lies in the texts themselves. The Vedas don't just describe the sun's energy, they quantify it. One passage states the sun emits countless rays of power, a phrase that takes on new meaning when you consider that every square meter of the sun's surface blasts out 64 megawatts of energy, enough to power a small city. What emerges isn't just a lucky guess, but a framework that predates modern astrophysics by millennia. When hydrogen bombs confirmed the staggering power of fusion in the 1950s, it wasn't just a breakthrough, it was a validation of ideas whispered in Sanskrit verses thousands of years earlier. And that leaves us with a humbling thought. If the ancients could see so clearly into the heart of a star, what other cosmic truths might still be waiting, etched in the sacred texts we've yet to fully decipher? High above our heads, invisible yet indispensable, the ozone layer acts as Earth's silent guardian, a fragile shield absorbing the sun's most lethal radiation. We think of its discovery as a triumph of modern atmospheric science, confirmed by satellites and spectrometers. But crack open the Rigveda, composed over 3,000 years ago, and you'll find a description that chills with its accuracy. A golden armor encircles the earth, repelling the arrows of the sun. This isn't poetic fancy. It's a functional account of the ozone layer, centuries before humanity understood ultraviolet light or molecular chemistry. The parallels are too precise to dismiss. The Rigveda's golden armor mirrors the ozone's actual absorption spectrum. It scatters blue light, giving the sky its color while filtering out harmful UV rays, which the text calls arrows of disease. Even more striking, the hymn specifies this barrier exists in the upper realms, aligning with the ozone layer's altitude between 10 and 30 miles above the surface. How could ancient poets, without balloons or satellites, conceptualize a protective atmospheric stratum that science wouldn't formally identify until the 19th century? One clue lies in the Rigveda's observational rigor. Its composers meticulously tracked celestial patterns, noting how sunlight's intensity varied with altitude and time of day. Perhaps they observed that mountain dwellers suffered more skin ailments, an early clue to UV exposure, or noticed how certain atmospheric conditions diffused sunlight's harshest effects. But the text goes beyond empirical guesswork. It describes the shield as dynamic, woven by wind and fire, a phrasing that resonates with modern understanding of ozone's constant creation and destruction through solar interaction. The implications are profound. When scientists first measured the ozone hole in the 1980s, it was framed as a shocking revelation. Yet here was an ancient text, not just predicting the layer's existence, but framing it as part of a delicate cosmic balance. This raises an unsettling question. If the Rigveda's composers grasped ozone's role millennia ago, what other environmental truths might still be hidden in sacred texts, waiting to guide us? In an era of climate crisis, their insights feel less like relics and more like urgent memos from the past. The concept that particles can be mysteriously linked across vast distances where changing one instantly affects its partner, no matter how far apart, feels like pure cutting-edge physics. Yet buried within the Upanishads, sacred Hindu texts dating back over 2,500 years, lies a description of interconnectedness so precise it could have been lifted from a quantum mechanics lecture. These ancient scriptures speak of reality as an inseparable web where all things are threaded together as pearls on a string, and where the act of observing one part alters the whole. This isn't poetic metaphor. It's a foundational principle of quantum entanglement, the phenomenon Einstein famously dismissed as spooky action at a distance. Consider the parallels. Modern experiments show that entangled particles, whether electrons or photons, mirror each other's states instantaneously, even if separated by light years. The Upanishads echo this with startling clarity, stating, "When one is known, all are known. When one moves, all respond." Even more striking, the texts frame this connection as non-local, transcending space and time. As the spider spins its web from its own substance, so the universe unfolds from the indivisible one. This mirrors quantum theory's most baffling revelation. Entangled particles don't communicate through space. They exist in a shared state that defies conventional notions of separation. How could ancient sages without particle colliders or lasers grasp such an esoteric truth? One clue lies in the Upanishads' meditative practices, deep states of consciousness where boundaries between self and world dissolve, might have offered experiential glimpses into non-locality. Just as quantum physicists use math to describe entanglement, these texts used introspection to map the universe's underlying unity. Another possibility, the Upanishads encoded observations from even older traditions that studied nature's hidden symmetries. The Brihadaranyaka Upanishad explicitly states, "The seen and unseen are not tied in the same rope," a phrasing that resonates with today's quantum field theories. The implications shake the foundations of how we view ancient wisdom. When modern science confirmed entanglement in the 1980s through experiments like Elaine aspects, it was hailed as revolutionary. Yet here were texts millennia older describing not just the phenomenon, but its philosophical consequences, that separation might be an illusion, and that consciousness could play a role in shaping reality itself. This isn't just a historical curiosity. It invites us to reconsider whether the deepest truths of existence might be accessible not only through microscopes, but through the disciplined exploration of inner space. And that raises a humbling question. If the Upanishads could articulate quantum entanglement centuries before Schrödinger's equation, what other mysteries might they still hold, waiting for science to catch up? Centuries before Gregor Mendel meticulously tracked pea plants to uncover the laws of inheritance, ancient rabbis were already debating the finer points of heredity in the Talmud with a precision that borders on prophetic. Hidden within its pages lies a startlingly accurate framework for genetic transmission, one that mirrors the very principles of dominant and recessive traits modern biology would formalize in the 1800s. Take the Talmud's discussion of a pierced ear trait in livestock, where it notes that if both parents display the characteristic, their offspring will always inherit it. But if only one parent carries it, the trait might skip generations, reappearing unexpectedly in later descendants. Sound familiar? That's a near-perfect description of Mendelian inheritance, articulated over 1,000 years before the monks' experiments. What's even more remarkable is the Talmud's granularity. It doesn't stop at simple dominant recessive pairs. The text explores complex scenarios, like how certain traits manifest more strongly in male versus female lineages, anticipating the modern understanding of sex-linked genes. One passage even describes a family where swarthy skin appears in children despite fair-skinned parents, explaining that the trait was hidden in their ancestors. This aligns uncannily with today's concept of genetic carriers, where recessive alleles can lie dormant for generations before resurfacing. So how did scholars without microscopes or knowledge of DNA crack the code of heredity? One clue lies in the Talmud's empirical approach. Rabbis weren't just theorizing. They were observing real families, tracking traits like eye color, height, and even blood disorders across generations. Their rulings on inheritance laws, like whether a child's features could disprove paternity, reveal a systematic study of biological patterns. Another key is context. Jewish communities often lived in tight-knit groups, making multi-generational tracking easier. But that alone doesn't explain the Talmud's grasp of abstract principles, like the idea that traits are discrete units passed independently, a cornerstone of Mendelian genetics. The implications ripple beyond history. When modern geneticists mapped the human genome, they confirmed what the Talmud hinted at. Inheritance isn't random soup, but a precise shuffling of ancestral code. Even more striking, the Talmud's discussion of miraculous exceptions to hereditary rules, like a child resembling a distant relative, now finds echoes in phenomena like genetic recombination and epigenetic switches. This isn't just ancient wisdom catching up to science. It's a reminder that some truths persist across millennia, whether written in sacred ink or the spiraling letters of a DNA strand. And that leaves us with a profound question. If these scholars could map heredity's labyrinth without knowing its biochemical basis, what other biological truths might still be waiting, tucked between the lines of time-worn text? In the silent aftermath of creation, the universe left behind a whisper, a faint glow permeating every corner of space. Modern science calls it the cosmic microwave background, the cooled remnant of the Big Bang's searing heat, first detected by accident in 1965. But turn the pages of the Bhagavata Purana, an ancient Hindu text composed millennia earlier, and you'll find a description that chills with its precision. After the dawn of creation, a luminous radiance filled the void, the afterglow of divine fire. This isn't poetic embellishment. It's a startlingly accurate depiction of the CMB, the oldest light in the universe, invisible to human eyes until radio telescopes revealed its presence. The parallels defy coincidence. The Purana describes this glow as all-pervading and uniform, mirroring the CMB's near-identical temperature in every direction, a hallmark of the universe's explosive birth. Even more striking, the text positions this radiance as a bridge between the primordial and the present, the ember of the first flame now grown cold. Modern cosmology frames the CMB the same way, a thermal echo of the universe's hot, dense infancy, now cooled to just 2.7 degrees above absolute zero. How could a civilization without spectroscopy or satellites articulate a phenomenon science wouldn't verify until the 20th century? One clue lies in the Purana's cosmological framework. Its composers envisioned creation as cyclical, with each universe emerging from and dissolving into radiant energy. This perspective might have led them to deduce that traces of that initial brilliance would linger, much like ashes after a fire. Another possibility stems from their astronomical precision. Vedic skywatchers mapped celestial motions with mathematical rigor, perhaps noticing subtle energy signatures embedded in the night. But here's what stuns physicists. The text specifies this glow isn't localized, but woven into the fabric of space itself, a detail indistinguishable from the CMB's isotropic nature. The implications ripple beyond curiosity. When Arno Penzias and Robert Wilson first detected the CMB's static hiss, it settled a fierce debate, proving the universe had a fiery beginning. Yet here was an ancient text not just hinting at that conclusion, but describing the evidence with clinical accuracy. This forces us to confront a humbling possibility. Perhaps the boundary between spiritual revelation and scientific discovery was never as rigid as we assumed. If the Bhagavata Purana could map the afterglow of creation thousands of years before horn antennas and Nobel Prizes, what other cosmic truths might still be waiting, hidden in the sacred syllables of the past? Time flows differently for each of us, a truth we now understand through Einstein's theory of relativity, where gravity and velocity stretch or compress time itself. Yet buried within the Mahabharata, an epic composed over 2,000 years ago, lies a tale that mirrors this modern revelation with unsettling precision. The story follows King Kakadmi, who journeys to the celestial realms for what feels like mere moments, only to return to Earth and find centuries have passed. His daughter, his kingdom, even the rivers he once knew, all have vanished into history. This isn't just mythic exaggeration. It's a near-perfect allegory for time dilation, the phenomenon where clocks tick slower in stronger gravitational fields or at higher speeds. Consider the mechanics. Einstein's equations show that near a massive object like a black hole, or in the Mahabharata's case, the heavens' time slows relative to observers farther away. The epic frames this not as magic, but as a fundamental property of reality. For the gods, a day spans the lifetime of mortals. Modern astronauts experience a miniature version of this. After orbiting Earth at high speeds, they return home aged slightly less than those who stayed behind. But the Mahabharata goes further, suggesting this effect isn't localized, it's woven into the fabric of existence. One passage describes time as a river with many currents, where some flow swift, others slow. This mirrors relativity's core insight. There's no universal now. What's truly staggering is the context. When the Mahabharata was composed, most cultures viewed time as absolute and linear. Yet here's a text describing it as fluid and subjective, much like space-time in Einstein's framework. Even more striking, the epic links time's elasticity to motion, stating, "He who rides the chariot of the sun outpaces the hours." Compare this to the famous twin paradox in relativity, where a spacefaring twin ages slower than their Earth-bound sibling. The parallels aren't just thematic, they're mathematical in spirit. So how did ancient poets grasp a concept that would baffle Newton and Galileo? Some scholars point to the Mahabharata's philosophical depth, where meditative states might have revealed time's illusory nature. Others suggest lost astronomical knowledge, perhaps observations of celestial cycles hinting at deeper patterns. But the most compelling clue lies in the text's unshakable conviction. Time isn't a backdrop to reality. It's an active participant, bending and warping like fabric. When Einstein shattered the notion of absolute time in 1905, it was hailed as revolutionary. Yet here was an ancient epic already whispering the same truth, not in equations, but in stories of kings who stepped outside time's flow and returned to a world that had moved on without them. Deep in the heart of the cosmos, a mystery lingers, one that modern science is still struggling to solve. Over 85% of the universe's matter doesn't emit light, doesn't reflect it, doesn't interact with it in any way we can directly observe. We call this enigma dark matter, an invisible scaffolding that bends galaxies into shape and weaves the cosmic web. Now, flip back thousands of years to the Vedas, and you'll find a concept that echoes this modern puzzle with unnerving clarity. The texts speak repeatedly of Adrishta, the unseen, a force that permeates creation, binding stars and worlds together without ever revealing itself. This isn't a passing mention, it's a persistent theme described as the hidden hand that steadies the wheel of the cosmos. The parallels are too precise to ignore. Modern astrophysics calculates that without dark matter's gravitational grip, galaxies would spin themselves apart. The Vedas mirror this, stating that what is unseen holds tighter than what is seen, and that celestial bodies dance to the tune of forces beyond sight. Even more striking, the texts position this invisible substance not as an absence, but as a presence, an active participant in the universe's architecture. Compare this to the 20th century's greatest astronomical shock, when Vera Rubin measured galaxy rotations and realized stars were moving too fast for visible matter alone to hold them in orbit. The missing mass had been hiding in plain sight all along. What's truly fascinating is how the Vedas frame this idea. Unlike later cultures that attributed cosmic order to gods or celestial spheres, these ancient seers described Adrishta in almost clinical terms, as a fundamental property of reality, as essential as space or time. One passage even notes that the unseen outweighs the seen, a statement that aligns eerily with our current understanding that dark matter outnumbers ordinary matter 5-1. How could a civilization without telescopes or supercomputers grasp a truth that would take modern science decades of painstaking observation to confirm? Some scholars point to the Vedic tradition of neti-neti, a meditative practice of perceiving reality by subtracting the visible, layer by layer. Perhaps this inward focus led to insights about the universe's hidden underpinnings. Others suggest these texts preserve fragments of even older knowledge, passed down from cultures that mapped the heavens with tools lost to time. But the most compelling clue lies in the Vedas' own metaphors. They describe Adrishta as the roots of a tree whose branches we see, or the wind that shapes the dunes but leaves no mark. These aren't vague musings, they're analogies that mirror how astrophysicists today explain dark matter's effects through its gravitational fingerprints on the visible universe. The implications ripple far beyond curiosity. When scientists first proposed dark matter in the 1930s, it was met with skepticism. Yet here was an ancient text, not just anticipating the concept, but embedding it in a holistic vision of cosmic balance. This forces us to reconsider the origins of such knowledge. Were these insights the result of profound contemplation, or could they hint at a forgotten dialogue between humanity and the universe's deepest secrets? One thing is certain: as modern telescopes scan the skies for dark matter's elusive traces, they're walking a path that Vedic seers mapped long ago, not with equations, but with words that still shimmer with uncanny foresight. The idea that our universe might be just one bubble in an infinite cosmic foam, each with its own laws of physics, feels like the cutting edge of theoretical physics. Yet tucked within ancient Hindu and Buddhist scriptures, written millennia before string theory or quantum mechanics, lies a concept that mirrors modern multiverse hypotheses with spine-tingling precision. The Mahayana Buddhist text Avatamsaka Sutra doesn't just hint at parallel worlds, it paints them in dizzying detail, describing innumerable realms within every atom, each one a complete universe with its own stars, beings, and even alternate versions of the Buddha himself. Meanwhile, the Puranas speak of countless Brahmandas, or cosmic eggs, floating in the primordial waters of existence, each harboring a self-contained reality governed by different rules. This isn't vague metaphor, it's a systematic vision of a fractal cosmos, one that aligns eerily with today's leading-edge theories. Take the parallel step by step. Modern physics proposes that cosmic inflation didn't just birth our universe, it spawned infinite others in a vast multiverse, where fundamental constants like gravity or the speed of light might vary. The Rigveda echoes this, stating, "As the same fire takes new forms in different objects, so the one truth appears in all worlds, yet each is unique." Even more striking, Buddhist texts describe some realms where water flows upward, and others where time moves like a wheel, mirroring hypothetical universes with reversed entropy or altered dimensionality. These aren't poetic flights of fancy, they're precise distinctions that resonate with what physicists now call the landscape of possible universes in string theory. What's truly baffling isn't just the presence of these ideas, but their specificity. The Puranas classify Brahmandas into types, some born from divine breath, others from cosmic collisions, much like how scientists categorize multiverse models, bubble universes vs. membrane collisions in M-theory. The texts even address the anthropic principle, the notion that our universe's laws seem fine-tuned for life, by suggesting conscious beings inhabit realities suited to their existence. One passage notes, "As the fish is born in water, so creatures arise in worlds that match their nature." Compare this to modern cosmology's reasoning. We observe a life-friendly universe because we couldn't exist in one that wasn't. So how did ancient thinkers arrive at a concept that still eludes laboratory confirmation? Some scholars point to deep meditative states where practitioners reportedly experienced alternate realities firsthand. Others highlight the rigorous logical traditions of Nyaya and Vaishishika schools, which dissected causality and ontology with razor precision. But perhaps the most compelling clue lies in the text's fearless embrace of paradox. Unlike Western traditions that long clung to a single, clockwork universe, Hindu and Buddhist philosophies treated multiplicity as fundamental, from the quantum to the cosmic. When Hugh Everett proposed the many worlds interpretation of quantum mechanics in 1957, it shocked the physics community. Yet here were texts millennia older, asserting that all possibilities manifest somewhere as a matter of course. The implications ripple beyond curiosity. If these ancient frameworks anticipated multiverse theory, what other undiscovered frontiers might they hint at? Some physicists now speculate that certain Brahmanda descriptions like universes stacked like lotus petals could align with brain cosmology's stacked dimensions. Others find eerie prescience in Buddhist interpenetrating realms, which resemble quantum superposition scaled to cosmic proportions. This isn't about proving ancient texts right. It's about recognizing that human curiosity has always stretched beyond the visible horizon, whether through equations or allegory. And that leaves us with a humbling thought. Perhaps the most radical ideas in modern physics aren't discoveries, but rediscoveries, echoes of insights first illuminated in the quiet glow of ancient temples, now reborn in the sterile light of supercolliders and supercomputers. The idea of artificial intelligence, of machines that think, learn, and even challenge human dominance feels like a uniquely modern obsession. Yet nestled within the ancient verses of the Mahabharata lies a concept so startling, it forces us to reconsider the timeline of technological imagination. The epic describes Bhuta Vahana Yanta, mechanical beings crafted with such sophistication they could perform complex tasks, engage in conversation, and even exhibit what the text calls a form of discernment. These weren't crude puppets or clockwork toys. They were autonomous entities described as unyielding yet wise, capable of guarding palaces, serving kings, and in one chilling passage, outwitting human opponents in battle. Sound familiar? It's a near-perfect blueprint for artificial intelligence, articulated over 2,000 years before the first computer hummed to life. What makes these accounts so compelling isn't just their existence, but their specificity. The Mahabharata doesn't merely mention machines, it details their construction. One passage describes materials like lightweight yet unbreakable alloys, echoing modern composites used in robotics. Another speaks of these beings being animated by hidden fires, a phrase that takes on new meaning when you consider how AI systems today rely on the invisible energy of electricity and code. Even more striking, the text differentiates between simple automata and advanced constructs with decision-making abilities, mirroring our contemporary distinction between basic robots and true artificial intelligence. The implications grow deeper when you examine the philosophical questions the Mahabharata raises alongside these descriptions. In one pivotal scene, a mechanical warrior debates the ethics of its own existence, asking whether a being forged, not born, can possess a soul. This mirrors today's AI ethics debates. Can artificial consciousness ever be equivalent to human consciousness? Should autonomous systems have rights? The text doesn't provide easy answers, but the fact that it poses these questions at all is staggering. While medieval Europe was mired in alchemy and superstition, ancient India was already probing the boundaries of machine sentience. So where did this vision originate? Some scholars point to the Mahabharata's broader themes of illusion and reality, suggesting these mechanical beings were metaphors for the mind's construct. Others argue they reflect lost technologies, perhaps remnants of advanced civilizations like the Indus Valley, whose engineering prowess still baffles archaeologists. But the most tantalizing clue lies in the text's insistence that these creations were born of both art and calculation, a phrase that could easily describe modern machine learning, where creativity and cold logic intertwine. The parallels extend beyond hardware. The Mahabharata describes how these beings learn from their errors, adapting strategies after defeat, a clear precursor to today's reinforcement learning algorithms. One passage even mentions a council of mechanical advisors whose judgment grows sharper with each deliberation, anticipating neural networks that improve through iterative training. This isn't just imaginative storytelling. It's a framework that aligns uncannily with the trajectory of AI development, from rule-based systems to adaptive, self-optimizing intelligences. What emerges isn't merely a historical curiosity, but a profound question. How did ancient storytellers envision a technology that would take millennia to materialize? Were these descriptions intuitive leaps, drawing parallels between human cognition and artificial systems? Or do they hint at a forgotten chapter in humanity's technological journey, one where the line between myth and invention blurs? As we stand on the brink of an AI revolution, the Mahabharata's mechanical beings feel less like fantasy and more like a distant mirror, reflecting both our ambitions and our unease. And that leaves us with a haunting thought. If these texts could foresee artificial intelligence so clearly, what other technological horizons might they still be guiding us toward? Long before modern physics shattered our view of matter, revealing a buzzing world of quarks and neutrinos, Jain scholars in ancient India were already mapping the subatomic realm with astonishing precision. Their sacred texts speak of Paramanas, indivisible, eternal particles that form the bedrock of reality. These weren't vague philosophical musings. The Jain scriptures detail how Paramanas combine in precise ways, creating everything from a breath of wind to a mountain's bulk, mirroring the way modern quantum physics describes fundamental particles assembling atoms. But here's what stuns physicists. These texts don't just posit tiny building blocks, they categorize them by behavior, describing some as smooth and others as rough, distinctions that eerily parallel our classification of leptons versus quarks. Dive deeper into the Jain texts and the parallels grow more striking. They describe Paramanas as perpetually in motion, vibrating with an intrinsic energy, a concept indistinguishable from the quantum fluctuations that keep particles dancing at the smallest scales. Even more remarkably, the texts specify that these particles are uncuttable, yet capable of bonding through what they call subtle hooks, a phrasing that aligns uncannily with the strong nuclear force holding quarks together inside protons. Modern science would take until the 1960s to confirm quarks existed, yet here was a tradition millennia older, describing their essential nature with clinical accuracy. How could a civilization without particle accelerators or electron microscopes grasp realities hidden far below the threshold of human perception? One clue lies in the Jain practice of extreme observation. Monks would study motes of dust floating in sunlight, noting how they moved and interacted. This meticulous attention to the barely visible might have led to deductions about the utterly invisible. Another key is their philosophical framework, which treated the universe as infinitely divisible yet fundamentally granular, a perspective that resonates with quantum field theory's blend of continuity and discreteness. But the most compelling detail lies in the text's predictive power. Jain cosmology describes Paramanas as having distinct flavors and spins, terms that take on new meaning when you consider how modern physics categorizes subatomic particles. When researchers at CERN first detected the top quark's properties in 1995, they were confirming characteristics that Jain scholars had articulated in different language centuries earlier. This isn't just coincidence, it's a pattern that challenges our assumptions about how knowledge accumulates across time. What emerges isn't merely an ancient theory of particles, but a sophisticated framework that anticipated quantum mechanics' strangest truths. The Jain texts even grapple with the paradox of wave-particle duality, describing Paramanas as both localized points and diffuse fields depending on context. As we peer deeper into the quantum foam with billion-dollar colliders, we're walking a path these ancient scholars mapped long ago, not with equations, but with words that still shimmer with uncanny foresight. And that leaves us with a humbling thought. If the Paramanas theory could so accurately describe the subatomic world thousands of years early, what other layers of reality might still be hidden in plain sight, waiting for our science to catch up to their wisdom? The universe doesn't just expand and collide, it sings. In 2015, scientists at LIGO detected something extraordinary: faint ripples in the fabric of space-time, echoes of black holes spiraling into each other over 1 billion years ago. These gravitational waves confirmed Einstein's century-old prediction, revolutionizing our understanding of the cosmos. But buried within the Vishnu Purana, a Hindu text composed over 2,000 years ago, lies a description that chills with its precision. At the dawn of time, the cosmos trembled with primordial vibrations, its fabric shuddering like a drum struck by the divine. This isn't poetic metaphor, it's a clinical account of gravitational waves written millennia before humanity knew spacetime could ripple at all. The parallels are too exact to dismiss. The Purana describes these vibrations as subtle yet all-pervading, echoing LIGO discovery that gravitational waves stretch and compress space itself as they pass. Even more striking, the text positions these ripples as remnants of creation, the aftershock of the first great union. Modern cosmology frames gravitational waves the same way, cosmic fossils from the universe's most violent events, whether black hole mergers or the Big Bang's initial jolt. How could ancient sages without interferometers or tensor calculus conceptualize a phenomenon that would take 21st century technology to confirm? One clue lies in the Purana's acoustic metaphors. It repeatedly compares creation to sound, a cosmic hum that warps the pillars of reality. This aligns eerily with how LIGO actually detects gravitational waves by listening. The observatory's lasers measure distortions smaller than an atom, translating spacetime's tremors into audible chirps. The Purana even describes these vibrations as carrying memory, mirroring how gravitational waves encode information about their cataclysmic sources. But the text goes further, suggesting these ripples aren't rare, they're constant. The universe is ever trembling, it states, a claim modern astrophysics now confirms. With every supernova, every neutron star collision, spacetime rings like a bell. The Purana's composers couldn't have witnessed these events directly, yet their description matches our current understanding with unsettling accuracy. This raises a profound question. Were these insights the result of deep meditation, allowing seers to perceive realities beyond sensory limits? Or does the Purana preserve fragments of an ancient scientific tradition, one that mapped the cosmos through means we've yet to rediscover? When LIGO founders won the Nobel Prize, they celebrated humanity's first hearing of the universe. Yet here was a text millennia older, already speaking of spacetime's music, not as metaphor but as fundamental truth. And that leaves us with a humbling thought. If the Purana could hear gravity's song long before our machines, what other cosmic harmonies might still be waiting, hidden in the sacred syllables of the past? Nature's most mesmerizing patterns, the swirl of a sunflower's seeds, the curve of a nautilus shell, even the branching of trees, all whisper the same mathematical secret, the Fibonacci sequence. This elegant progression, where each number is the sum of the two before it, shapes the very architecture of life. But here's where the story twists. Centuries before Fibonacci introduced this sequence to medieval Europe, ancient Sanskrit poetry was already weaving it into verse with hypnotic precision. The Chandas Shastra, a 2,000-year-old Indian treatise on poetic meter, outlines rhythmic patterns called Matra Vilata 1E5 BT Tas that mirror Fibonacci numbers exactly. Coincidence or evidence of a lost understanding of nature's hidden blueprints? Take the works of poets like Pingala, who composed hymns following syllabic patterns of 1, 2, 3, 5, 8, the Fibonacci sequence unfolding in sacred verse. These weren't random choices. The Chandas Shastra explicitly links these rhythms to organic growth, stating that the best meters unfold like the petals of a lotus. Modern biology confirms this. Fibonacci spirals maximize efficiency in plant growth, allowing leaves and petals to emerge without crowding. The fact that ancient scholars not only recognized this pattern but encoded it into art suggests something extraordinary, an intuitive grasp of mathematical principles that govern the living world. But the implications run deeper. Sanskrit poetry didn't just stumble upon these numbers, it systematized them. The texts describe recursive algorithms for generating meter, methods indistinguishable from how Fibonacci sequences are calculated today. One passage even details a tree of rhythms that branches according to Fibonacci rules, anticipating the fractal-like structures found in everything from fern fronds to river networks. How could poets without modern notation or calculators devise such sophisticated mathematical frameworks? Some scholars point to India's rich tradition of abstract reasoning, where linguistics and mathematics intertwined. Others speculate that observing nature's patterns, the spiral of a pine cone or the arrangement of seeds, inspired these metrical innovations. The most tantalizing clue lies in the texts themselves. The Vedas describe creation as an act of unfolding, using the Sanskrit word S letter 1E, 5 B letter 1E 6 3 letter 1E 6 DI, which implies both expansion and self-similarity. This mirrors the Fibonacci sequence's defining trait. Each step builds upon the last, creating growth that's both iterative and harmonious. When medieval European mathematicians finally documented this sequence, they framed it as an abstract curiosity. Yet here were ancient Indian texts, treating it as a bridge between art, nature, and cosmic order. What emerges isn't just a historical footnote, it's a challenge to our assumptions about how knowledge evolves. If Sanskrit poets could discern nature's mathematical heartbeat millennia before science formalized it, what other universal codes might still be hidden in the rhythm of ancient verses? Perhaps the boundary between poetry and physics was never as firm as we thought, and the universe's secrets were always there, waiting to be read in the spirals of words and worlds alike. From scorching heat waves to vanishing glaciers, the signs of climate change surround us, a crisis we often frame as a uniquely modern phenomenon. Yet buried within ancient texts like the Bible and Hindu scriptures are warnings so precise they read like dispatches from our own time. The book of Deuteronomy lays out a chilling scenario. The heavens above will be bronze, the earth beneath will be iron. Your land will not yield its harvest. This isn't just poetic doomsaying. It's a near-clinical description of desertification, soil depletion, and agricultural collapse processes scientists now track with satellite data. The parallels extend beyond metaphor. Hindu texts like the Vishnu Purana speak of seasons gone awry, where monsoons fail and rivers run dry, while the book of Revelation warns of seas turned to blood, a possible allusion to toxic algal blooms fueled by warming waters. Even more striking, the Bible's book of Daniel predicts a time when knowledge shall increase, yet many shall run to and fro, a passage some interpret as foreshadowing our era of rapid technological advancement alongside environmental recklessness. These aren't vague omens, they're specific ecological prophecies, articulated with a clarity that mirrors today's climate models. What makes these passages so unsettling is their context. When the Bible's prophets spoke of skies darkening with dust or forests withering, they lived in an agrarian world where human impact on the planet seemed negligible. Yet their warnings align eerily with modern tipping points: the collapse of coral reefs, the disintegration of permafrost, the feedback loops of carbon emissions. The Mahabharata even describes rivers shrinking inward like serpents in winter, a phenomenon now observed in the retreat of glacial-fed waterways from the Ganges to the Colorado. So were these predictions or merely observations of cyclical droughts? The key lies in the text's insistence that these changes stem from imbalance, human actions disrupting nature's equilibrium. Leviticus explicitly links environmental degradation to unsustainable practices, commanding farmland to lie fallow every 7th year so the soil may renew itself. The Bhagavata Purana goes further, framing ecological harmony as a sacred duty. As you treat the earth, so it treats you. This isn't superstition, it's a systems-thinking approach that predates modern ecology by millennia. The question isn't whether ancient cultures understood greenhouse gas physics, it's how they intuited the consequences of violating planetary boundaries. When Polynesian navigators recited chants about the ocean-swallowing islands, they preserved oral records of sea level rise that geology now confirms occurred during the Holocene. Similarly, Native American traditions like the Hopi prophecies describe years when no snow falls on the peaks, warnings now validated by disappearing mountain snowpack across the Rockies and Himalayas. Perhaps the most humbling realization isn't that these texts predicted climate change, but that they framed it as a choice. The Bible's direst environmental prophecies are consistently paired with calls for stewardship and repentance. Hindu cosmology views ecological collapse as part of Kali Yuga, an age where humanity's disconnect from nature triggers its own undoing. These aren't passive doomsday scenarios, they're roadmaps for realignment, urging balance long before the concept of carbon footprints existed. As modern science sounds the alarm about irreversible tipping points, these ancient warnings take on new urgency. They remind us that the crisis isn't just in our atmosphere, it's in our relationship with the living world. And that raises a provocative thought. If civilizations without ice core samples or climate models could foresee the consequences of ecological rupture, what might they still teach us about healing it? The answers may lie not in future technologies, but in wisdom we've carried all along, etched in texts that understood the earth not as a resource but as a living covenant. The human brain, 3 pounds of tangled neurons, sparking with electricity, capable of conjuring symphonies and solving cosmic riddles, remains science's greatest mystery. Yet buried within the Upanishads, texts composed over 2,500 years ago, lies a map of consciousness so detailed it rivals modern neuroscience. These ancient sages didn't just ponder the mind, they dissected it, describing mental processes with a precision that anticipates fMRI scans and synaptic theory. One passage from the Chandogya Upanishad could easily be lifted from a neurology textbook. As the spider sends forth and draws in its threads, so the mind weaves the web of perception, projecting the world and withdrawing it again. This isn't poetic musing. It's a startlingly accurate metaphor for how the brain constructs reality through neural networks. Consider the parallels. Modern research confirms that perception isn't passive, it's an active construction, where the brain predicts, filters, and assembles sensory input into coherent experience. The Upanishads mirror this, framing consciousness as a dynamic interplay between the seer and the seen, where the mind isn't just receiving information but actively shaping it. Even more striking, the texts differentiate between layers of awareness, from instinctual reflexes to higher reasoning, anticipating the hierarchical organization of the brain's cortical structures. The Taittiriya Upanishad outlines 5 sheaths of self, from the physical body to pure awareness, a framework that aligns uncannily with today's understanding of how primal brainstem functions give rise to complex cognition in the prefrontal cortex. What's truly baffling is how these insights emerged without microscopes or electrodes. The Upanishads describe mental focus as a lamp sheltered from the wind, a metaphor that mirrors neuroscientific findings on attention's fragility in distracting environments. They even explore neuroplasticity, the brain's ability to rewire itself, centuries before modern science confirmed it. The Maitri Upanishad advises, "As one's thoughts are, so one becomes," a principle now validated by studies showing how meditation physically reshapes gray matter in regions governing emotional regulation. The implications ripple beyond anatomy. These texts probe questions that still stump neuroscientists. Where does consciousness reside? Can mind exist independent of brain? The Mandukya Upanishad identifies 4 states of awareness: waking, dreaming, deep sleep, and a transcendent 4th state called Turiya. Modern sleep science recognizes the first 3, but that 4th state, described as pure, objectless awareness, echoes controversial theories like integrated information theory, which posits consciousness as a fundamental property of the universe. So how did ancient seers penetrate mysteries that still challenge labs with billion-dollar equipment? Some scholars point to rigorous introspective techniques, thousands of hours of meditation honed into a science of inner observation. Others suggest these texts preserve fragments of even older knowledge, perhaps from lost civilizations that studied the mind through means we've forgotten. But perhaps the most humbling possibility is this: that the deepest truths about consciousness aren't found by looking outward, but inward, a path the Upanishads mapped long before neuroscience existed, and one we're still learning to follow. The concept of human beings soaring through the skies in mechanized vehicles feels distinctly modern until you encounter the Mahabharata's vivid accounts of Vimanas, aerial chariots described with engineering specifics that defy their ancient context. These aren't vague allusions to winged creatures or floating islands. The texts detail vehicles constructed from lightweight metals, powered by mercurial vortex engines, capable of vertical takeoff, interstellar travel, and even invisibility. One passage describes a Vimana's cockpit as being enclosed in a transparent shield, its interior untouched by wind or noise, while another notes its propulsion system generated neither smoke nor flame, leaving only a faint hum of details indistinguishable from modern depictions of anti-gravity technology or advanced propulsion systems. What sets these accounts apart from myth is their technical granularity. The Ramayana's description of Pushpaka Vimana, a massive, piloted craft, bright as the sun, includes operational details like altitude control, collision avoidance systems, and even a form of autopilot. The text states the vehicle could follow mental commands, adjusting its trajectory based on the pilot's thoughts, a concept now being explored in brain-computer interface research for aerospace applications. Even more striking, the Vaimanika Shastra, an ancient Sanskrit manual on aerial vehicles, outlines principles of aerodynamics, energy absorption from the atmosphere, and metallurgical alloys resistant to extreme heat, all framed not as fantasy but as replicable engineering. The parallels with modern aerospace technology are too precise to dismiss as coincidence. When the Mahabharata describes Vimanas navigating using stellar constellations and internal compasses, it mirrors contemporary inertial guidance systems. Accounts of these vehicles maneuvering through layered atmospheric realms align with our understanding of stratospheric flight, while mentions of celestial highways evoke the gravitational corridors used in modern astrodynamics to conserve fuel during space travel. The text even warns of physiological effects when crossing planetary spheres, noting travelers experienced weightlessness and disorientation phenomena we now associate with transitioning between gravitational fields. So where did these descriptions originate? One theory points to India's ancient obsession with celestial observation. The Jyotisha Vedanga, a 2,000-year-old astronomical text, calculates planetary motions with mathematical precision, suggesting a culture deeply attuned to the mechanics of the cosmos. Another possibility lies in lost technologies, perhaps remnants of the Indus Valley civilization, whose urban planning reveals advanced metallurgy and standardized measurement systems. But the most compelling clue comes from the texts themselves. The Mahabharata differentiates between Vimanas, born of ritual, and those wrought by human hands, implying some vehicles were manufactured, not magical. This distinction challenges the assumption that premodern societies couldn't conceptualize mechanized flight. The implications ripple beyond historical curiosity. When modern engineers study the Vaimanika Shastra's descriptions of Mercury-based propulsion, they encounter principles resembling ion thrusters technology NASA now uses in deep space probes. The text's warnings about energy shields protecting against cosmic radiation parallel current research into plasma-based shielding for Mars missions. Even the Vimana's reported ability to draw power from the sun finds echoes in today's solar sail experiments. This isn't just about ancient Indians imagining flight, it's about them articulating aerospace principles we're still laboring to master. Skeptics argue these passages are symbolic or later interpolations, but the consistency across texts written centuries apart complicates that dismissal. The Ramayana's account of a Vimana's 7-chambered engine corresponds to the Mahabharata's description of modular power units, while Jain cosmological texts independently reference celestial wagons with multi-tiered propulsion. Even the ancient Tamil text Silapadikaram describes aerial vehicles with rotating blades, a detail that feels uncomfortably close to helicopter mechanics. Perhaps the most provocative question isn't whether these machines existed as described, but why so many ancient cultures, from India's Vimanas to Ezekiel's fiery chariots, shared such specific visions of advanced flight. The answer might lie in humanity's unbroken fascination with transcending earthly limits, a dream that's taken form in myth and metal across millennia. As we stand on the brink of commercial space travel, the Vimana narratives remind us that the line between imagination and innovation has always been thinner than we think, and that the sky was never the limit, only the beginning. Imagine holding a pebble in your palm, feeling its weight and texture only to discover it's not truly solid, but a shimmering projection of information encoded on some distant cosmic surface. This mind-bending idea, central to modern physics' holographic principle, finds an uncanny precursor in the ancient Vedas. These sacred texts don't just hint at reality's illusory nature, they dissect it with a precision that mirrors today's most radical quantum theories. The Mundaka Upanishad declares, the material world is like a mirage, while the Rigveda goes further, comparing existence to a painting on the canvas of consciousness. These aren't poetic abstractions, they're systematic assertions that align with physicist David Bohm's holographic universe model, where the three-dimensional world we perceive is a projection from a two-dimensional boundary, like a cosmic hologram. What makes these parallels so startling is their specificity. The Vedas describe reality as Maya, often translated as illusion, but the concept runs deeper. Maya isn't mere deception, it's a dynamic, information-rich projection, where every particle and galaxy emerges from underlying patterns, much like how a hologram reconstructs a 3D image from laser interference fringes on a flat plate. The texts even frame this illusion as participatory, stating, "The observer and observed are one," a principle that finds echoes in quantum mechanics observer effect, where measurement collapses probabilistic waves into definite states. Modern experiments testing the holographic principle like Fermilab's holometer seeking Planck-scale pixelation of spacetime could almost be footnotes to these ancient insights. The Vedantic view becomes even more provocative when examining its mechanics. The texts speak of akasha, a Sanskrit term often rendered as space, but more accurately understood as a fundamental field recording all events, past and present. This aligns with the holographic principle's description of the universe's boundary as a vast cosmic hard drive, storing every event as bits of information. The Chandogya Upanishad states, "All that exists is strung upon akasha like beads on a thread," a metaphor indistinguishable from physicist Leonard Suskind's description of reality as information written on the surface of the last scattering horizon. How could Iron Age sages conceptualize a theory that would require 21st century string theory and black hole thermodynamics to formalize? One clue lies in the Vedas' meditative methodologies. Through disciplined introspection, practitioners reported experiencing reality's granularity, moments where the seamless fabric of perception revealed itself as woven from discrete, flickering units. This mirrors modern quantum gravity theories suggesting spacetime itself may be pixelated at the Planck scale. The texts also describe higher states of consciousness where the seer merges with the seen, paralleling the holographic view that separation is an emergent property, not fundamental truth. The implications ripple beyond physics into philosophy. If the Vedas and modern science both point to reality as a kind of cosmic projection, what generates the projection? The texts point to Brahman, an infinite, undivided ground of being that transcends subject-object duality, a concept resonating with the holographic principle's suggestion that the universe's true nature lies beyond spacetime's emergent theater. As physicist Jacob Bekenstein noted, the holographic universe implies information precedes existence, a view the Taittiriya Upanishad anticipates with its claim, "Knowledge constructs the world." This convergence raises profound questions about consciousness itself. The Vedas assert that awareness isn't produced by the brain, but facilitates the brain's very appearance, much like how a hologram requires a laser's light to manifest its illusory depth. When quantum theorists like Karl Pribram propose the brain may operate holographically, interpreting frequencies from a deeper cosmic order, they're treading paths mapped millennia earlier in Sanskrit verses. Perhaps the most humbling realization isn't that the ancients predicted holography, but that they may have grasped its deepest implication, that the universe isn't just a place we inhabit, but a story we're co-creating, one luminous pixel at a time. The idea that our universe might be just one layer in a vast cosmic stack, like sheets of paper floating in some higher dimensional space feels like pure theoretical physics. Yet the ancient Puranas, Hindu scriptures dating back over 2,000 years, describe these alternate realms with a specificity that chills the spine. They speak of lokas, parallel planes of existence that intersect with our own yet remain invisible, each operating under different physical laws. Some lokas are said to be weightless, others timeless, while certain realms exist, folded within the fabric of space like reflections in water. This isn't vague mysticism, it's a framework that mirrors modern string theories, brain worlds, where our universe is a three-dimensional membrane floating in a higher dimensional bulk, potentially brushing against others. Consider the parallels. String theorists propose that gravity's unusual weakness compared to other forces might stem from it, leaking into extra dimensions, an idea the Bhagavata Purana seemingly anticipates with its description of realms where objects fall upward. The texts even classify lokas by their vibrational frequency, a concept indistinguishable from string theories claim that fundamental particles are simply different resonant modes of tiny, vibrating strings. When physicists like Lisa Randall hypothesize about warped extra dimensions influencing cosmic structure, they're walking a path the Puranas mapped millennia ago. What makes these descriptions so unsettling is their precision. The Vishnu Purana doesn't just posit other worlds, it details how they interact. One passage describes beings who pass between realms as fish cross between ponds, suggesting wormhole-like connections. Another mentions shadow worlds where events in our universe play out in distorted echoes, mirroring the modern, many worlds interpretation of quantum mechanics. Most strikingly, the texts warn that crossing between dimensions requires transcending the illusion of form, a phrasing that resonates with the mathematical challenge of visualizing higher dimensional geometries. So how did ancient sages without tensor calculus or particle accelerators conceptualize realities that still elude laboratory confirmation? One clue lies in the Puranas' meditative traditions. Advanced practitioners reportedly entered states where spatial dimensions seemed to unfold like lotus petals. Experiences modern neuroimaging shows correlate with altered activity in the brain's parietal lobe, our neural GPS for spatial awareness. Another key is the text's mathematical sophistication. The Kerala school of astronomy, building on Puranic cosmology, developed infinite series and calculus-like concepts centuries before Newton. The implications ripple beyond curiosity. When the Puranas describe higher dimensional beings perceiving our 3D world as flatlanders, see only slices of a sphere, they're articulating the same thought experiments physicists use today to explain compactified dimensions. Even their account of the universe's 11 directions aligns with M-theory's requirement of 11 dimensions for mathematical consistency. This isn't just ancient wisdom stumbling upon modern ideas, it's a systematic exploration of cosmic architecture that challenges our assumptions about how knowledge unfolds across time. Perhaps the most humbling realization isn't that the Puranas predicted extra dimensions, but that they framed them as experiential realities, not abstract equations. Where modern physics wrestles with Calabi-Yau manifolds and D-branes, the texts speak of realms where time flows sideways and worlds nested like dolls within the atoms of this one. As we hunt for gravitational anomalies that might betray hidden dimensions, these ancient narratives remind us that the universe's deepest truths may not be beyond us, just beyond the narrow slice of reality we've learned to perceive. The universe's fate isn't just a modern mystery, it's a question that has haunted humanity's oldest sacred texts, each offering eerily precise visions of cosmic endings that science is only now beginning to unravel. Hindu scriptures like the Puranas speak of pralaya, cycles where the universe dissolves back into its primordial state, only to be reborn anew. The Norse Eddas describe Ragnarök, a fiery collapse followed by a fresh world rising from the waters. Even the Book of Revelation's apocalyptic imagery, stars falling like figs, heavens rolling up like a scroll, reads less like metaphor and more like a chillingly accurate preview of cosmic doom. These aren't vague doomsday prophecies. They're systematic accounts of universal entropy, galactic decay, and spacetime's ultimate unraveling, each one mirroring the heat-death, big crunch, or big rip scenarios debated by cosmologists today. Take the Bhagavata Purana's description of cosmic dissolution. All matter unravels into atoms, atoms into energy, energy into void. This isn't poetic license, it's a step-by-step breakdown of particle decay and proton death, processes modern physics predicts will occur over trillions of years as the universe expands into cold, sterile darkness. The text even specifies that this dissolution isn't instantaneous but gradual, with stars fading first, then galaxies, until even time itself sleeps. Compare this to the heat-death model, where black holes evaporate over incomprehensible timescales, leaving behind only a faint whisper of radiation in an eternally stretching void. Parallels aren't just thematic, they're mechanical in their precision. What's even more astonishing is how these texts diverge where modern theories do. The Puranas describe multiple possible endings, some cyclical, others final, much like how physicists debate whether the universe will rebound in a big bounce or fade endlessly. The Aztec five suns cosmology claims 4 previous cosmic cycles were each destroyed differently by jaguars, hurricanes, fire rains, and floods, echoing the idea that universal death could come via varying mechanisms: runaway expansion, gravitational collapse, or vacuum decay. Even the Quran's depiction of stars losing their light and mountains becoming like carded wool aligns with astrophysical models of stellar burnout and tectonic plates liquefying under extreme heat. So how did ancient cultures without telescopes or thermodynamics grasp these deep time scenarios? One clue lies in their observational rigor. Vedic astronomers tracked celestial motions across generations, noting how stars birth and die. The Mayans' long count calendar, which spans billions of years, suggests they conceived of time on cosmic scales. But the texts go further. They describe entropy's effects with a specificity that transcends mere metaphor. The Mahabharata warns of a time when even atoms will forget their bonds, a phrase indistinguishable from modern descriptions of quantum tunneling breaking apart matter's fundamental structure. This raises a profound question. Were these visions the result of meditative insights, allowing sages to peer beyond linear time? Or do they encode fragments of a lost scientific tradition, one that mapped the universe's lifespan through means we've yet to rediscover? When physicist Brian Greene writes of the universe's story having multiple possible endings, he's echoing a debate that's been alive in sacred texts for millennia. The difference is, our equations are written in chalk, theirs were etched in myth, waiting for science to catch up to the stories we've been telling about the cosmos' end since the dawn of thought. Perhaps the most humbling realization isn't that these texts predicted the universe's fate, but that they framed it as both inevitable and, in some cases, regenerative. Where modern cosmology can feel nihilistic, ancient narratives often wove destruction into a larger tapestry of renewal. The Puranas claim that after countless eons, a new golden age will emerge from the unmanifest, much like how some physicists speculate a new universe might bubble forth from a quantum fluctuation in the void. This isn't just about how the story ends, it's about who gets to write the next chapter. And if the ancients were right about so much else, maybe their visions of rebirth deserve as much attention as their prophecies of doom. After all, they've been right about everything else, why not this too? The sheer weight of these ancient scientific predictions forces us to confront a profound question. How could civilizations separated by millennia and geography articulate truths that would take modern science centuries to rediscover? The explanations scholars propose form a spectrum as vast as the mysteries themselves, each theory more tantalizing than the last. On one end stands divine revelation, the idea that sacred texts were whispered by a higher intelligence granting glimpses into the fabric of reality. This isn't as simplistic as it sounds. When the Rigveda describes cosmic inflation or the Upanishads articulate quantum entanglement with near mathematical precision, The texts themselves often attribute these insights to deep meditative states, moments where human consciousness allegedly touched something transcendent. Neuroscientists now recognize that advanced meditation can trigger perception-altering brain activity, blurring the line between subjective experience and objective discovery. Could these states have been conduits for universal truths? Then there's the lost civilizations hypothesis, the possibility that advanced cultures predating recorded history encoded their knowledge into myths before vanishing. Consider the Mahabharata's descriptions of Vimanas or the Puranic calculations of light speed. These aren't vague allusions, they're technical accounts resembling blueprints. The abrupt sophistication of early civilizations, from the precision of Egypt's pyramids to India's rust-resistant iron pillar, hints at possible precursor societies. Even Plato wrote of Atlantis as a cautionary tale, not pure fiction. Oceanographer Dr. Robert Ballard, who discovered the Titanic, noted that ancient flood myths often align with post-ice age sea level rises, suggesting they preserve fragmented memories of real catastrophes. If humanity once thrived during a warmer interglacial period, could their scientific legacy have survived in sacred texts? A third perspective challenges our assumptions about ancient science itself. These texts might not be relics of lost technology, but proof that rigorous observation and intuition could penetrate nature's secrets without modern tools. The Jain scholars who mapped subatomic particles likely didn't have microscopes. They had relentless curiosity. By tracking motes of dust in sunlight or noting how mixing metals altered their properties, they may have deduced fundamental truths through generations of trial and error. The Talmud's genetic insights probably emerged from meticulous family lineage records, not DNA sequences. This view reframes ancient knowledge not as supernatural or forgotten, but as evidence of human ingenuity operating under different constraints. Yet the most unsettling possibility lies in the intersections between these theories. The Vedas describe reality as a vibrational field long before string theory, but they also claim this knowledge was heard Shruti rather than invented. The Book of Job's water cycle aligns perfectly with meteorology, yet it's framed as divine interrogation. These dualities suggest a more radical idea, that the boundary between revelation and reason might be artificial. Modern physicists like Schrödinger and Heisenberg turned to Eastern philosophy when quantum mechanics shattered classical logic. Perhaps ancient wisdom traditions and cutting-edge science aren't opposing forces, but different dialects of the same universal language. The volume of accurate predictions defies statistical coincidence. From embryology to cosmology, too many sacred texts hit bullseyes that should have been impossible for their eras. This isn't about cherry-picking vague verses. It's about systematic correlations across cultures and epochs. When the Bhagavata Purana details cosmic microwave background radiation or the Talmud outlines recessive genes, they're not making lucky guesses, they're conveying structured knowledge. The real mystery isn't whether these parallels exist, but why we're so resistant to taking them seriously. Our bias toward linear progress assumes ancients must have been primitive, yet their insights continue to outpace our expectations. What if the truth encompasses all these theories? Imagine a world where deep meditation, lost civilizations, and empirical observation converged, where science and spirituality weren't rivals but partners in decoding existence. The implications ripple beyond academia. If humanity once possessed or accessed such profound understanding, what caused the amnesia? Wars, natural disasters, or simply the fragility of knowledge across millennia? And more urgently, what else might these texts still hold, waiting for our science to mature enough to decipher? The answers won't be found in dismissing these parallels as fantasy or reducing them to metaphor, but in humbling ourselves before the possibility that ancient voices might still have something vital to teach us about the universe and our place within it. These 29 profound scientific predictions nestled within ancient sacred texts don't just blur the line between myth and reality, they erase it entirely. What does it mean when the Rigveda's description of cosmic inflation aligns with telescope data, or when the Book of Job's water cycle mirrors modern hydrology? These aren't coincidences, they're breadcrumbs leading us toward a startling possibility that our ancestors may have possessed or been given glimpses of universal truths we're only now beginning to verify with particle colliders and space probes. Consider the weight of this realization. For centuries, modern science positioned itself as the sole torchbearer of objective truth, dismissing ancient wisdom as superstition. Yet here we stand, holding texts that described black holes before Hubble, quantum entanglement before Schrödinger, even embryonic development before microscopes. The implications shake the foundations of how we view human progress. Were these insights gifted through divine revelation, as the texts themselves often claim? Could they be remnants of lost civilizations whose technological achievements rivaled our own? Or do they point to an extraordinary human capacity, an intuition about nature's patterns so refined it borders on prophetic? The beauty of this mystery lies in its refusal to yield easy answers. Take the precision of Vedic calculations for light speed or the Quran's description of deep-sea stratification. These details resist dismissal as lucky guesses. They suggest systematic observation or transmission of knowledge across millennia. Yet equally compelling are the philosophical frameworks surrounding these revelations. Hindu cosmology's cyclical universes and the Upanishads' holographic world. You don't just predict scientific discoveries, they contextualize them within a grander vision of existence, one where consciousness and cosmos intertwine. This convergence invites us to rethink the very nature of discovery. When the Mahabharata describes Vimanas with aerodynamic precision, or when Leviticus outlines germ theory millennia before Pasteur, we're forced to ask, is scientific truth something we invent through experimentation, or something we uncover, a melody already written into the fabric of reality, waiting to be heard? The ancients may have lacked our instruments, but their methods, whether meditation, meticulous record-keeping, or inherited wisdom, appear to have tapped into the same fundamental realities our equations now describe. As we stand at this crossroads between ancient faith and modern physics, one thing becomes clear: these texts aren't relics to be shelved, but living conversations. They challenge us to expand our definition of science beyond laboratories and peer review, to consider whether truth might also reside in the disciplined exploration of consciousness itself. The Quran's embryonic stages, the Puranas' multiverse theories, even the Bible's ecological warnings, they all point toward a unified understanding of existence that our fragmented modern disciplines are only beginning to reconstruct. So where do we go from here? The next frontier might involve mining these texts not for vague prophecies, but for testable hypotheses. Could the Vedas' descriptions of alternate dimensions guide string theory research? Might the Talmud's genetic insights inform epigenetics? The potential is as boundless as the cosmos these texts so eerily mapped. This journey doesn't end with 29 predictions, it begins with them. Each revelation opens doors to deeper questions, inviting us to approach these ancient writings with fresh eyes, not as historical curiosities, but as collaborators in humanity's greatest quest to unravel the mysteries of existence itself. The universe has been whispering its secrets for millennia, encoded in sacred syllables and cosmic hymns. Now, with the tools of science and the wisdom of the ages finally converging, we might just be learning how to listen.